Now, in today's meeting, we are going to look into binary operations or binary systems. We are going to look at the operations and applications. Operations and the applications. Under these operations and applications, we are going to look into how to express numbers in bases other than 10 and the conversion of from base 10 to other bases and vice versa. Now we're going to look at expression of numbers or expressing numbers in bases other than 10, in bases other than base 10. Okay, let us start with that one. Now, remember that base 10 is what we call binary. Base 2 is what? Binary. We have base 8. Base 8 is octa. That is octal system also. Octal-based system. Now, as many, we have hexadecimal and so on. So, this is not just what we have, but we are going to look into conversion from base, expression of numbers in different bases other than base 10. But before that, let us consider a particular number in base 10. Let us see how it's described. If you have a number like this, maybe 1, 3, 4, 5. You know, when you open up this number, this means 1000 plus 300 plus 40 plus 5. If you have a number like this, we have it as 1000 plus 300 plus 40 plus 5. Let's just open it in base 10. That is expressing numbers in powers of their bases. We tag this one. Let's tag it expressing numbers in powers of their bases. Expressing digits in powers of their bases. And now we say, assuming that this one is in base 10. Now let us start. We have 1345 as this. 1000 plus 300 plus 40 plus 5. This means 1 times 1000. This means 3 times 100. This one means 4 times 10. And why this one is 5 times 1. See how we are going gradually. See how we are going gradually. Now, this thing means 1 times 10 times 10 times 10 plus 3 times 10 times 10 plus 4 times 10 plus 5 times 1. Now, let us look into the powers now. We have 1 times 10 raised to power 3. 1, 2, 3 plus 3 times 10 raised to power 2 plus 4 times 10 raised to power 1. There's no 10 here, which means it is 10 raised to power 0. And you know that any number raised to power 0 is 1. So we see here that we have expressed this number 1345 in powers of what? 10. Now we have to say that well, this is base 10. You see the number itself is already in base 10. Now, having taken note of this, if we have this number as any other number like 1, 3, 4, 5 to base x, or maybe let's say base y, it will now be, you see, since this thing is base 10 here, and look at how it is. We have what? 1 times y raised to power what? 3. Replace the 10 with y. Now we have 3 times y squared plus 4 times y 1 plus what? 5 y 0. Y raised to power 0. Or I can split it as what? Or y raised to power 0. You see what we have here? Now, you see what you have here? So, in case they give you number to express in powers of each base, this is how you do it. So, you have expressed 1345 base y in powers of what? Base y. You see how this one went? You started from here to decrease them, to reduce them in their own powers of base 10. You got to this stage. Now, this is the base 10. We have it here. Now, if you happen to replace this 10 with what? Y, which means that this gives us this. So, we have 4 digits here, and the highest power is 3, which means that what? If you have 5 digits, the highest power will be 4. If you have 10 digits, the highest power will be 9. So, please take note of these things. Say now. If you look at this number, this is what 204,751. Okay, it was normally, we call it in base 8, 304751 base 8. Now, if you check, the highest digit here is 7. This can never be in base 7. If you have 7 here, it cannot be in base 7. It will be in a base that is higher than the highest digit you have here. Do you understand? So that's how to note this thing. If you have this and you are asked to put it in base what, maybe it will be written here base 2. You know that it's very, very wrong. So, like we have 3 here, we have 4 here, we have 7, we have 6. See, there's no number for a base that will be less than 7. So we have in base 8, remember, we said here in our previous one that if the digits are n in number, the highest power will be n minus 1. So to this effect, we have 6 digits, the highest power will be 5. So we have 3 times 8 raised to power 5 plus 0 times 8 raised to power what? 4 plus 4 times 8 raised to power 3 plus what? 7 times 8 raised to power 2 plus 5 times 8 raised to power 1 plus what? 1. You see it now. Remember that there is 8 times 8 raised to power 0 on that end, at that end. So this is what we have. We have expressed this number in powers of base 8. That's how we express numbers. And now, when you express a number in powers of base 8, you have this. And when you finally evaluate this, you are going to get it in what? In base 10. Please. When you express a digit in powers of base what? Of each base, and you finally evaluate what that thing gives, you are going to what? Get it exactly in base 10. Please. So that is it. Now, for what you said, we say that when you express a digit in a powers of each base, and you finally evaluate it, you are going to what? Get what? A value or a digit in base 10. If you say 1, 3, 4, base 5, when you express it, you are going to have 1 times 5 raised to power 2 plus 3 times 5 raised to power 1 plus what? 4 times 1. Now, this one gives us 25 times 1, 25. This one gives us 15 plus 4. We have what? 44. You see, that's what? You look at what you now have. You see, they are not they are the same, but you express this one in powers of its base. When you now evaluate it, you are going to get it in another form, which is in base 10. So when you are asked how do you convert digits from one base to another base, you now say that you convert a digit from another base to base 10 by expressing it in powers of that base. Do you get me? I now write it down. You convert what? A digit or digits in another base to base 10 by what? Expressing it in powers of its base. Then evaluate or simplify it. You have 134 base 5. When you express it in powers of its base, you have this. Then simplifying it, you have this. Which means that what? 134 base 5 is same as 44 base 10. Now, converting base 10 to other bases. Remember we said when you want to convert or express a number in the powers of its base, giving any base apart from base 10, which we have done earlier, you express in powers of its base. When you finally simplify it, you are going to get a number in base 10. Now, how then do we go back? That is converting base 10 to other bases. What you do is to continue to divide with that base you want to convert it to until you get to 0. So look at it here. Like that example, 44 base 10 to base 5. What do you mean? You have 44. You keep dividing with 5. 5 divided 4, see, a 4, you have 8, that is 14, remaining what? 4. Some people can use R. Let me use R. Now, we have 5 divided 8, you have what? 1, remaining what? 3. 5 divided 1 is 0, remaining 1. So you take it from down and go up. You count it from down and move up. So taking it from the down part up, you have that what? 44 base 10 will give us 134. 134 base 5, which was what we had initially. We said when you want to convert from base 10 to any base, you keep dividing with that base you are converting it to till you get to 0. Okay, we say 36 divided by 8. We have 36 dividing 8, we have what? 4. That is 32. Remaining what? 4. So 8 divided 4 is 0, remaining 4. So you go from down to up, which gives us what? 4 base 8. So we have that 36 base 10 is something as what? 44 base 8. To get this thing done, to convert 569 base 10 to base 8, you keep dividing 569 by 8. We have 569 divided by 8. 8 divided 56. What do we have? 77. 8 divided 9. We have 1 remaining what? 1. 8 divided 71. We have what? 8, because 8 times 9 is 72. That's 8 times 6 is what? 8 times 8 is 64. So the difference is 7. 8 divided itself is 1, remaining 0. And 8 divided 1 is 0, remaining 1. We go from down to up to give us 1071. This is the in base 8. So that's good. So we have this one written. Okay. Earlier, we told you that the first thing you do is to expand in powers of the base. The first one you do, expand in powers of that base, of this base zone. Now, the second method you can also use is by repeated multiplication. By repeated multiplication. So we are going to show an example of these two like we did earlier. So the first case, A, convert 135 base 6 to base 10. Now we have, using the first method, we have 135 base 6 to be 1 times 6 raised to the power 2. Remember that this is 3 digits, we have 2. Plus 3 times 6 raised to the power 1. Plus 5 times 1. Remember, 6 raised to the power 0 is 1. So this is what? 36 plus 18 plus 5. So when you evaluate this, you're going to get an answer in base 10. This is 23 plus this will give us what? 59 base 10. Now, for the second method, we have 135. Now, this one, the first digit will be multiplied by 6. You have what? 6. You add 3. What do you have? 9. So 9 times 6. You have what? Let me write it down. You have what? 54. 54 will now be added to what? 5 will be added to it to give us 59. One times 6, 1 times 6 plus 3 is this. Now that value times 6, this plus the last digit, this. That's how to do it. Let's pick an example again and work using this method. Now in this case, you convert 2451 base 7 to base 10. We have this written spaced out like this. The first digit will be multiplied by 7 to give us what? 14. 14 plus 4 gives us what? 18 times 7. What do we have? 18 times 7 gives us 70 plus 56 to give us 126. So 126 plus 5, we have what? 131. 131. Then you times it by what? 7. Then whatever you have, you add 1 to it. Now this gives us 917 plus 1 to give us what? 918 in base 10. Two times 7, 14. You bring down this one to add to it to give us 18. After that, you multiply with the base. Then you have 126. You add this one. You have this multiplied by that base. You have this, and then add the last digit. Don't multiply again. So this gives us the value in base 10. Let us find a second method to confirm this. 2 times 7 raised to power 3 plus 4 times 7 raised to power 2 plus 5 times 7 raised to power 1 plus 1. Now you know that 7 raised to power 3 is same thing as what? 343. 2 times 343 plus 4 times 49 plus 35 plus 1. So this gives us 686 plus 4 times 49, it gives us 196 plus 35 plus 1. Summing this thing up gives us 686 plus 196 plus 35 plus 1 gives us 918 in base 10. Conversion of base numbers from one base to another other than base 10. Now look at this now. What do you mean by this example? Converting base 9 to base 8. Now this pattern is very simple. The pattern is very simple, and I would like you to pay much close attention to this. Now, assuming this is base 9, this is a base 9. I'm going to give you a general formula we are going to use. And here is base 8, or any base, as case may be. So, between this is what we call the hub. The hub is base 10. Now, when you convert base 9, first of all, to base 10, you then convert that base 10 to base 8. If you want to return back, you convert base 8 to base 10, and then convert base 10 to base 9. So the base 10 serves as a central system to connect to other bases. When you want to convert from one base to another, you are going to pass through base 10. Once you pass through base 10 will now, you convert it from base 10 to other base, and vice versa. Now look at this case. Convert 52 base 6 to base 7. What you do is to first of all, convert 52 base 6 to base 10. Now let's just get the general formula we have. This is our 52, 5, 2. You start with 1, base 6, that's 6. So this is 6 raised to power 0. This one is 6 raised to power 1. If there's another value here, it should be 6 raised to power that 2. So here, see, this time this is 2, this time this is 30. So add these two, you're going to get 32. That is when you add them. 30 plus 2, you're going to get 32. So this is 32 in base 10. So the next thing you do is to convert 32 base 10 to base 7. Now, in converting 32 base 10 to base 7, you are going to divide by base 7. 7 divided this is 4. That is 28. Remaining what? 4. 7 divided 0, remaining 4. So it goes from and up. So we have what? 4 base 7. So we can now finally say that the value we had initially, which is 52 base 5, is equal to 4 base 7. Okay, sorry, it's 52 base 6 to base 7. So this is it. Convert 11011 base 2 to base 3. Now in this case, to convert base 2, first of all, go to base 10. That is by expanding base 2 in powers of each base. Now we have what? This is 1, 2, 3, 4, 5. 5 digits, and the highest power will be 4. 1 times 2 raised to the power 4 plus 1 times 2 raised to the power 3 plus 0 times 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 1 times 1. Or you can say 1. Now this is 2 raised to the power 16. 2 raised to the power 4 is equal to 16. 16 times 1 is 16 plus 8 plus 0 plus 2 plus 1. This is 24 plus 3, 27 base 10. So you have gotten base 10, that's 27 base 10. You are not going to convert this 27 base 10 to base 3 by dividing continuously. So we have 27 base 3 divided here, you have 9, remaining 0. 3 divided 9, you have 3, remaining 0. 3 divided 3, you have what? 1, remaining 0. 3 divided 1, you have 0, remaining 1. So you count from up to down to up. We have what? 1, 0, 0, 0 base 3. So we now conclude with this down that 11011 base 2 is same thing as 1000 base 3. So here is our conclusion that this is equivalent to 11011 base 2. Convert the following to base 10 and also convert the following to base 5. This one conversion between bases other than base 10, why this one conversion to base 10. So in our next meeting, we are going to now look into the binary system proper, the base 2 proper, including those that have decimal fractions. Thank you for being part of today's class. We appreciate you. Do join us and don't forget to subscribe to our videos. God bless you.